All right, well, let's rock and roll. Good morning, good afternoon, everyone. Again, my name is Chris Doran. I am a technical sales specialist for ITM Instruments. Thank you for joining us for our webinar today. It's brought to you by ITM University. Just a quick note, we had a slight change of plans for today's webinar. The original topic, the original title was going to be EV charging and solar, common pains and points and solutions. Today, however, in the preparation of getting all this together, we realized that we probably wouldn't have enough time to cover all of it. So given this, we've made a slight change to the focus of the presentation today, and the title is better aligned with solar trends and PV systems, troubleshooting PV systems safely. And we are going to set up another webinar to go over the EV charging in the future. May not be in 2022, could be at the beginning of 2023, but stay tuned and we'll keep you posted on that future webinar. So we do apologize for anyone who was looking forward to the EV charging side of things. Like I mentioned, we are going to reschedule that, and we will keep everyone who registered and participated in this webinar abreast with all the info for that webinar upcoming. That being said, we are going to cover a good amount of information over the next 45 minutes or so, and we will have time for a Q&A portion at the end of the presentation. Throughout the presentation, if you have any questions on a particular slide, anything that we're covering, use the question feature to submit any and all of your questions. Again, we'll get to it at the end of the presentation during the Q&A period. ITM and Fluke have been working closely together for many years. We pride ourselves on being a leading distributor of Fluke in Canada. This is a result of our dedication to offering you our product expertise, our customer service, and our competitive pricing. Presenting the webinar today is Sean Silvey from Fluke. Sean has been with Fluke as a product application specialist for the past 7 years. Prior to working at Fluke, Sean was in the HVAC industry for 15 years, working on residential and commercial applications. In addition to his wealth of technical product expertise and experience, Sean has become an integral member of Fluke's Clean Energy Initiative, focusing on tools for the EV charging and solar segments. So Sean, I will turn the presentation over to you.
Well, thanks, Chris. And yeah, thanks again for kind of just going through what we're going to be presenting today. With so much going on with EV and solar, it was definitely better to break the two presentations apart. We have so much going on with solar. Thank you everyone for attending, and thank you ITM for allowing me to do this presentation with you. So again, today's session is going to be over solar trends and troubleshooting those PV systems. So we've got a lot of material, and let's jump right in. So agenda today, we're going to go through and see some trends in the system. We're going to identify what that PV system looks like, all the different components in that, some of the roles that are happening in that, working safely in that environment, obviously choosing the right tools for that job, and then troubleshooting. This is kind of the key win. What we're going to be looking at is the panels, all the loads, the inverters, and our combiner boxes. And then we'll wrap up with a summary and any questions at the end. So just some trends in the solar industry, and this was just based on 2021's numbers, but you can see that 46% has been added just in solar generation. Now these trends are for the US, but you can see that solar is not going away. It's grabbing more and more people are adopting it. Solar installations, as you can see, 19% growth just on the solar installations aspect of it. We're talking 23.6 gigawatts of DC capacity that's been generated. Every year there's a 7% year-over-year growth. In just even the residential installations, we saw 4.2 gigawatts of DC generation on that one. Ironically, even on that utility scale, utility companies are picking up more and more. They're adopting doing a blended with their energy generation, and you can see nearly 17 gigawatts of DC was on that one as well. Ironically, California has been really a leader in the capacity for generating solar, but in 2021, Texas took over that mark. So Texas now has more capacity and is generating more than California is. And it's really incredible that the states are adopting this and moving forward. So let's kind of look at some of the segments. As you can see here, this is a picture of like a solar utility scale environment. The acreage that is needed for this is huge. Obviously, there's multiple solar arrays. All of these are tied into combiner boxes. These combiner boxes are then going back to either one single inverter that could potentially be at 1500 volts or even greater on some of these. You know, there's a lot of panels out there. There's panel degradation going on, thousands of tests that have to happen if you can think about this just in the commissioning aspect of this. So a lot of reporting. These are critical because daily you're seeing output generation of what these systems are looking like. They're going from the solar array to that inverter, and that inverter, they're actually then connected to some type of step-up transformer and going directly out onto the grid. So that it's just, as you can see in this picture, a lot of landscape and a lot of real estate for these types of installations. But the component level is still the same, whether we go into the residential or commercial. We still have solar panels, we have solar arrays. Some of them will be, again, connected to some type of combiner box and then going into an inverter. On all of this, you could have battery backup storage as well, which is another aspect that has to be tested. But again, the components are very similar, just the size of them have shrunk. But obviously, when we get into that solar or that utility aspect, very large, very capable, very capable with a lot of voltage. Typically in our world, residential was running at 600 volts, commercial was running at 1000 volts, and then now our utility level was jumping up into that 1500 volt DC range. We're now seeing those voltages step up even more. Residential is getting close to that 1000 volt mark, and even commercial is jumping to the 1500. And there's talk now of even going to 2000 volt or even higher on some of the utility level. So incredible voltages, very large systems. So let's kind of look at some of the infrastructure of what this is. You know, the solar panels are really one of the key components to generating that electricity. It's a single cell photovoltaic cell that contains semiconductors that's going to convert that sunlight into electricity. That sunlight is going to be converting that, that into voltage and current. Once we put a lot of these panels into in series, now we can step up that voltage and step up that current. Now, as you can see here at the bottom of it, I love this display because it really shows the way these systems are set up. You can go from your solar panels, all of those are tying into multiple combiner boxes where the technician could typically go and do a lot of troubleshooting from that aspect. And then depending on the system, that DC charge could be going to very large battery storage backup systems where it's charging those batteries, or it could bypass that and go just straight into the inverters and straight out onto the grid. But with all these multiple panels, you could have multiple failures, whether it's a heat issue, a fracture, a crack issue in it. Again, solar is in the environment. It needs the sun. So obviously you're going to have environmental conditions as well, whether it's wind, dust, anything of that. Wildlife could cause failures on this as well. So just pretty incredible the amount of the solar panels, and I'm sure you've seen them if you drove by, of just the different tests that need to be happening at this aspect of the game. Now, when we look at all that, as I mentioned, all of these go to a combiner box, and all of these strings are tying into this one area, which each one is, all of these strings are fused. And then from this point here, we've got two major conductors going to the inverter. Now this, again, it houses your fuses assemblies. That way we can get in there and check on that. This is where you're going to see short failures, short circuit failures, something of that nature where it's popped the fuse. This is kind of the go-to for the technician when he's out into the field. He'll be able to establish if he's got equal amperage or voltage coming off of his lines, and then from that point can go back to those solar arrays and see which one potentially could have a fault or is not generating exactly. Now from that, as I mentioned, some of these systems do go into a battery storage application. Again, with batteries, we need to maintain them. You know, we want to make sure that they're above that 90% capacity. They're ready to be discharged. What I've seen in this aspect is in this utility style setting, the battery storage is a twofold. It actually helps maintain good voltage going into the inverter and keeps a solid DC level on that to be outputted to the AC side. But also too, during peak demands, like in California, Texas, wherever that may look like, they can open up these battery banks during those peak demand times and get more out of that. Again, we need to be able to check these battery systems. A lot of these are controlled, where you can go and look at it off of a controlled, you know, like a database type of system. But again, we would need to go out and test these and make sure that the batteries are set to go and working correctly. And then finally, really the key one here is going to be your inverters. The inverters are making the magic. It's taking that DC electricity, turning it into the AC, either putting it directly out onto the grid, or it's putting it into your house or to the, you know, something of that nature. There are regular checks that need to be happen on the inverter. Typically, these are done annually if it's residential or commercial. And then as I mentioned with the utility level, they are looking at these daily. They're seeing what the generation output is on a daily level to see if anything's changed. The inverters are incredibly smart. They've got a lot of interface with them that allows a communication to some type of SCADA system or some type of computer system to where they can see if an inverter goes down, something of that nature. Again, if you think about it, all of these solar installations are typically out in areas where not too many people are. So they have to be connected to be able to determine if something goes down, and they can generate a work order to get a team out there to determine what's going on. And then finally from this, after all of that generation going through that inverter, again, it's going to be going into a substation. Typically, it could be up to 480, 600 volts, going up to a step-up transformer, and then out into the main system. So that's kind of how that is. Now, if you have any questions about how the systems are, please hold those to the very end, but it seems pretty simple. I mean, we have our solar panels all tying into our combiner boxes. From there, we're either going to battery storage or we're going directly into our inverter and then out and being consumed. So some of the critical roles in this, you've got your PV designers, those electricians that are actually at that initial stage of doing the installation. Your solar tech or installer, who is also part of that installation aspect. That's kind of the key players in this, because they're designing this and they're setting it all up to run. They're out in this environment, they're installing the panels, they're confirming that the racking is all set up, everything's tied in. They're using multiple tools to make sure that these conductors don't have any shorts. You can imagine the miles of wire and conductors that are being used in these types of installations. You have your solar advisors who are also contributing and helping with the overall design and aspect of this. And then finally, once this system is installed and we're actually generating electricity, now we have an operations and maintenance team that's going to come in, and you'll have a manager that's dealing with that team and generating work orders to continue to keep that operation going. So what does the PV designer and electrician do? Well, they're out there designing the system and they've got a plan. Maybe it's a utility level. They say that they want to have a site that can generate so many megawatts or even gigawatts of energy coming off of it. That's where that designer is going to come in and design the system out. He's going to know the components, the output of each of the panels, which panels he needs to get, which of the inverters would work best for that system, and really starts going in and laying out the blueprints of that system. That electrician is also going to be then taking those blueprints and tying them in and starting to lay that out. Now, your solar tech and your installer, they're the ones that's really out there in the field now putting nuts to bolts. They're putting up the racking, or they have a team that's putting up the racking. They're setting in the panels. They're getting the trenches dug. Some of these systems are fixed. Some of these systems actuate and rotate based on where the sun is. All of those take into consideration, and that's where your solar tech and installer is going to be really working out there and troubleshooting the equipment, making sure that it's all getting installed correctly. Now, your advisor, he's going to come out and make sure that the load profiles were set up accordingly to those environmentals. When they decided that they're going to install this in Northern California, does it actually do what it's supposed to do? So they're going to make sure that the system capacity works, and they're going to get consistent power coming off of that. And then finally on this, you have your operations and maintenance, and I'm sure we've all heard that before. These are the representatives, or the guys, gals that are going to come out, and they're going to be coming in and doing all the troubleshooting or maintaining the equipment after it's been installed. They're going to make sure that it's functioning correctly, and that, again, the design of this system is outputting accordingly to what the demand was and what they've got it. So with all of that and with all those roles, and you could see all of the systems, all of the different components of the solar systems and how this is, there are a ton of wiring and connections. There's a lot of wiring harnesses. Your wire management is huge, especially if you have actuating and rotating equipment. We want to make sure that nothing's pinched. Typically, a lot of this stuff goes back to a combiner box, and it could be exposed to the elements. And then from that point, it's going to be buried in the ground going up to the inverter. So there's a lot of tools that need to be happening on that. You know, just the PV array alone is another aspect. There are companies who come out and all they do is come and clean the PV arrays. And that's all they do. They don't touch anything else. They'll come in and sweep out just to get the most out of that. And especially if those environments have birds, where you might have droppings landing that, or very harsh conditions with dust, where that could start, degrading the output power of the system. And even some of these on a commercial level, they could be on roofs. We want to make sure that nothing, because we penetrated the rooftop, we set up that racking, we don't have any additional leaks. These are all components that have to come out. And even on that battery maintenance, as I mentioned earlier, making sure that your battery storage is up to speed and you're ready to go. So let's kind of look at who's doing what and what tools they might need to go out there and work with. So obviously, if you're troubleshooting your solar PV panels, just about every one of the technicians and the people who we've called out here, your solar advisors, your installers, your maintenance managers, all of them are going out to troubleshoot what the system would look like on just the panels. They're going to need a meter. They're going to be able to have to measure voltage and current coming off of that. They need to have an irradiance meter, because they need to know, based on the panel manufacturer's data plate, that this much irradiance is going to give me this much voltage and current coming off of that panel. And even at times, they may need a thermal imager to be able to go out and look for those cracks in the system. You can see if a bypass diode has failed just by taking a thermal imager and looking out of it. But again, as I mentioned, what happens if the output voltage and the current go down? Well, either sometimes one panel may go down, or the whole line would go down. And this is where they're going to be starting to trace out that system. They're going to be either looking at that through a thermal imager, or they're going to be looking at that with a DMM and going through and checking and seeing where my voltage output would be. Typically what happens is that technician is going to go, like I had mentioned before, to the combiner box. From the combiner box where everything is tied into, they can do voltage and current checks. From that point, they can identify which string of panels could be the potential problem, and it helps them narrow it down. They can then once go out there and once they determine that, go and start doing initial investigation on that array. Again, maybe it's a damage. I've seen pictures of hail that have come through and just wiped out solar systems. Their arrays just get plummeted with the hail and you get massive holes in it. I've seen in certain conditions, and these are all typical environmental, a blizzard came through and literally wiped out. It just damaged multiple panels. It was incredible pictures that I saw. But all of that is basically from the array, so that technician is going to be using some type of meter, some type of irradiance meter, and even a thermal imager to go out and check for all of that. They're checking for that loose wiring. They're checking for any frayed or broken wires that might happen that need to get cleaned up, and then going back to the fuses. Now, again, as I mentioned, using a meter is going to be the key one. And this is where I like to throw in our category ratings conversation. Typically, all solar environments are category 3 environments when it comes to your meter. So look at your meters if you're in this world. Make sure that you have the right meter for the right job. If you're in these 1500 volts environments, you need a Cat 3 1500 volt rated meter. So make sure that, again, you're using the right tool for the right job, because you may be the only technician out there. A lot of times I don't see a buddy system on these big sites. They typically send one technician to do the job. So you want to make sure that you have the right tools, and you have the tools that you're going to need to carry around, because you're going to pull up to a site and start walking and doing a tremendous amount of walking to try to determine where your fault is to get that corrected. So let's look at the loads. So again, this is coming off of your PV system. This is coming off of all of your back to the combiner box, and this could be going even to your inverter. So again, looking at that, again, who's doing all of this? Every one of the personas that we talked about earlier. What's in their tool bag? Again, they're looking at the voltage, the current. You might need a scope meter to be looking at your output of the AC side of your inverter, a DMM, and again, a thermal imager. Thermal imagers are huge in this environment, as we can look for hot spots either on the panels themselves, at the combiner boxes, or at the inverter. Now, the PV load, as I mentioned, it's used to operate that's part of the system. We want to make sure that you're able to go out and do fuse checks, breaker checks. You're using a DMM or a clamp meter in that aspect, but you're doing continuity checks to see what that's happening. Those are going to be kind of one of the key wins on that. If you do find, obviously, a fuse blown or tripped, you got to figure out what caused it. Being in the HVAC industry for many years, you'd go out and go to a system and a fuse blew. Why? It's the number one question. You just don't go and replace the fuse. You understand the situation. Why did the fuse even break? The fuse is there for safety. It's there for a reason. So that's where we want to start doing some investigations, running through the system and making sure why that fuse blew and get that corrected. So when we put a new fuse in, we're ready to go again. But there's several stuff that could be happening just on the load side of it. And again, broken wires is huge. Dirty connections could be a part of this. Ground faults. One of the biggest problems that I've heard so far with solar systems are ground faults. That's where we get either a short circuit or a voltage, something going to ground is what it means. It's a ground fault. And that's a panel issue. Could be a panel issue going to the racking, and then that is taking that extra voltage and going to ground, or it trips the fuse out as well. So that's again where you're going to go back to that combiner box to determine what's happening with your load. You know, if the load's still not working correctly, that's when you're going to have to really start breaking down and looking at other components, getting your meters out, checking your voltages, checking your currents. You're doing that investigation and doing some backtracking to see what was happening. I was called out to do an investigation on a site in Oregon, and sure enough, everything was working great from the system, but when it went from the inverter to the step-up transformer, they were having problems. This is where we actually took an insulation tester and started doing some tests. We were megging out the wires. We were looking what that number looked like. Come to find out, when they buried that line, somebody had nicked one of the conductors. Once it got heated up and started working right, it shorted out and the system shut down. It was keeping the load from continuing to do its job. So again, recognizing that, knowing what tools, but again, that technician went through that whole system and then he finally determined where that problem was persisting between the inverter and the step-up transformer. So let's talk about the inverter, because man, there's a lot of stuff going on with this. Not only do you have components going in on the DC side with capacitors, all the components there, and then now we're taking that and moving it to AC. We've got frequency we need to be concerned about, balance of load that we need to be concerned about. All of the personas again are going to be working on that inverter. As you can see in this picture, there is a multitude of products that are going to be helping us. Not only did we have that DMM or clamp meter to help us with voltage and current measurements, we may need a scope meter to see what's going on. Obviously, that thermal imager is going to be a big win to check for heat signatures, but now we may even have to throw in a power quality unit. We may need to be looking at the DC power side as much as the AC power side coming off of this. One site I went to in Georgia, the inverter kept tripping out. They went through, investigated the system. Come to find out, it was actually harmonics and transient issues coming from the utility side, and it would go back to the inverter. The inverter recognized it and tripped out. We had to use a power quality unit to go in and validate those numbers and see what that looked like to then go back to the utility to say this was an issue. Again, great tool to be able to analyze and troubleshoot that system. So you're going to be looking at a multitude of products on that inverter, between electrical components with boards, capacitors, you name it. I mean, they're filled, and the bigger the inverter you get, the bigger the components you are. Again, the inverter is converting this DC to AC, you know, this usable AC power. And one of the key things is also taking that AC and giving it a frequency wave. Obviously, here in the US, we're at 60 hertz. So we want to be able to analyze that and troubleshoot that as well. We want to make sure that on that inverter side of it, we are looking at that the load is correct and that the balance of voltage and current coming out of it is correct as well. That's where we're going to be using a multitude of those products like the thermal imager, the clamp meter, the DMM, to do all this troubleshooting. This is where we can go in and validate that what we're seeing from the combiner box is the same voltage. You will get a little bit of voltage drop and loss from the combiner box to the inverter, but it shouldn't be a lot. Again, these are issues that you would want to look at and determine and go back to that inverter to see what's happening. The inverter is going to, they're smart, as I mentioned. That's typically what happened was the inverter tripped, gave a warning, sent it out on the system, it generated a work order, and from that point, they were able to then send a technician out and do some troubleshooting. Some of the times the inverter, you'll have to even call the inverter manufacturer and see what the heck happened with it, what was going on, and do some troubleshooting at that aspect to work with that. When I was in the HVAC industry, that happened a lot of times. Some of the components were very complicated, some of the computer systems on some of these systems, and a quick phone call allowed you to call their technical support, and you were able to troubleshoot that and see which component failed to get that system up and running. So again, you're going to have fuses, you're going to have tripped breakers, you're going to have broken wires on these systems. Again, having the right tool to be able to go in and troubleshoot that and identify that. That's some of the key wins on this inverter. You may need to get additional people involved on the inverter. If you're qualified to work on that inverter, then you can, but if not, you have to get a technician from the inverter manufacturer to come out and do that troubleshooting as well. As I mentioned too, a lot of these inverters are tied to the utility, and that's another aspect where you may need to reach out to the utility to bring something down, either pull a fuse. That way you can work on that as well. And finally on these, we're looking at our combiner boxes. Combiner boxes can be used with all the personas again. Every one of them will be looking at it to make sure. And again, you're going to be looking at either your voltage and your current. You could use a scope meter even on that DC side, looking at seeing what's happening at your combiner box, and a thermal imager as well. Now, when you're in the system, you're going to be looking at your amperage. You're going to be looking and calculating all what your amperage and your voltage is coming off of this. This is also a good way to check if you do have ground faults, because you can pull your fuses and take a digital multimeter and go between your hot and your ground and your DC positive and your DC negative, and see if you have equal amount of voltage there or it'll drop out. There was a company in Georgia that reached out, and that's how they were doing it. They were actually taking a DMM, pulling the fuses, and then going between positive and negative and making sure they had equal amount of voltage there. If they didn't have equal amount of voltage, they knew they had a ground fault, and they could start doing that investigation there back on the panels. Also too, at your combiner box, the technicians are able to take multiple wires in it and be able to see in a grouping, does all of my amperages look equal? Again, if the system was designed correctly, the irradiance is correct on all of the panels, I should have equal amount of voltage and current coming off of each string, or relatively close to it. This is a good way to go to your combiner box and do some analysis to see. The combiner box is going to have your fuses, where again, that's where you're going to be troubleshooting and seeing what's happening with the system. Multiple parts are happening in this, multiple areas where we can have a problem go down, whether it's the arrays, all going back to the combiner boxes, all tying into the inverters. All of that is then troubleshooting the load going into it to making the system work. So now let's get into, I'm going to go pretty quickly because we're going to talk about components, products, and what that would look like to help you in those environments. As I mentioned before, make sure that your tools are category rated for these environments. If you're out in, like it says here, if you're out working on solar panels, that is considered a category 3 environment. Know your category rating and make sure the tool that you have is appropriate for that job. This is a great illustration because you can see the solar panels are Cat 3, going through the inverter is Cat 3. As soon as I go outside that inverter and start getting back onto the utility, that is considered a category 4 environment. And then once we go out of our utility back into consumption, it goes back into that Cat 3 and Cat 2. So know your meters, know what tools you need. As I mentioned through this whole entire aspect, having voltage and current measurements is huge. So have that right meter to be able to work with that. Whether it's a thin jaw capability, the IP54 rating is your environment. That is your ingress protection. That helps when it's raining or you have dust in there. Know that those particles won't get inside your meter to cause a problem. But having the right tool for that is going to be a big win. Also, too, a radiance. So having a radiance meter is going to allow you to validate what your sun output is. It's your watts per meter squared going into the solar panel. From that, you're going to get a curve analysis and be able to determine based on that irradiance, you'll know how much voltage and current should be coming out of the panel. This is huge because if you've got panel failure, maybe it's a degradation of the panel, excuse me, this one tool alone would allow you to be able to determine that, obviously with your clamp meter and your DMM. Also, too, having just a straight out DMM is going to save you on a lot of spots as well. Having something that's going to be rugged, reliable. This meter here is IP67 rated. So that is waterproof, dustproof, shockproof. Perfect meter to be out in the environment with these solar systems. So this will go up to 1,000 volts. So perfect based on your voltage. Whether if you're in that utility environment, there are some utilities that do split everything apart and keep it within that 1,000 volt range. So just kind of know the specs, know who designed it, and what their output should be on that. Now, when I was mentioning that Oregon site, we used a 1555 insulation tester. This allowed us to get out there and do some meg tests on those wires and validate that the insulation was broke down in that case, or it's not. This is also part of the commissioning aspect. When you're out doing the initial installations of this, this is part of commissioning. You will need to do some insulation tests and validate that everything is good to go and you don't have any breakdown as well. Insulation testing is also critical, that there's just a known practice that we want to double the value of our insulation test based on the voltage. What I mean by that is Romex wire for our houses. It's basically what, 14 gauge, 3 wire, 2 wire, it's got a ground on it. Even though we put that in our house at 120 volts, that wire is actually rated for 600 volts. We would want to double the value of that. So in a sense, we would do a 1200 volt test as an insulation test against that type of wiring. The larger the conductors, the larger the output voltage would need to be during these types of insulation tests. Good practice, just wanted to throw that out there as well. And then also too, you'd be looking at a scope meter. Again, the scope meter is going to be great when you're looking at the output or input side of your inverter, or you could be looking at your combiner box with this and being able to see what your system's doing using your scope meter. One of the keys is thermography. I can't stress enough, thermography is a huge one. Some of these big sites, they actually have now drones that have thermography on them, a thermal imager built on the drone itself, and that they're doing annual scans or even biannual scans of the system, and then be able to take that and put it into their reports and see if any failures are happening or what's going on. But even a handheld device is going to allow you to walk through that system, see if you have any hot spots, see any of your bypass diodes are blown on the panels themselves. You could see hot spots in your combiner box as well as in your inverter, and being able to do some troubleshooting and analysis with your thermal imager. Now, we did mention briefly about the battery storage systems. You'll need a tool to be able to analyze that each one of those batteries is ready to go and working correctly. So have a battery analyzer on site. That'll help you determine, and especially during the commissioning aspect. Typical battery analyzers, unless you know the battery manufacturer's information, you'll want to do a pre-analysis and testing on that to where later on we can start doing some trending analysis of those batteries, making sure that they're working correctly. But a good battery analyzer is going to allow you to validate and determine that. The next ones are going to be important, especially on that AC side. Now, the Norma 6004 power analyzer will do DC and AC power analyzing. It's one of the first ones out there. Typical analyzers will only do AC. So this is a huge win to be able to validate what's happening on the input as well as the output. You're going to be able to do some inverter efficiency measurements with having this type of meter. And again, even on the 1777, again, a power quality unit is going to allow you to make sure, like on what I mentioned earlier, that site in Georgia where the utility was causing the tripping aspect, having a good power quality meter on the AC side of it is going to allow you to then analyze if I've got good voltage, I've got no unbalance of voltage and current that's coming out of my inverter, and also too determining if I have any additional harmonics or anything else coming from the utility side that might trip that system. And then finally, I like to throw this one in because this will help you if you are working on the utility aspect with these systems. If you're the technician that helps on the AC side, mainly of the inverter, that utility guy may also need an acoustic imager. It's going to help detecting any partial discharge, anything of that nature on that utility aspect. So in summary, man, we've talked a lot about the whole system, but start right by testing right. You know, check for those ground faults, make sure that you have the right tools for the right job. Integrate testing into your installation workflow. It's going to actually save you time and money. One of the components I didn't talk about was a proving unit. You know, that's part of the NFPA 70E standard. Prove that your meters are working correctly prior to going out and doing your work. Prove that it's going to work. Do that dead live test on that. But you know, having like power quality units is going to help you troubleshoot those harmonic problems that could be out there. And again, just practice safety in the workplace. That's the key win on that. Use the right PPE for the right jobs. Use your right meters for the right jobs. Part of my safety session that I talk about is the meter and test leads are an extension of your PPE. So we want to make sure that those tools are rated correctly for being out in the field. So I know we're just about time, but I want to thank everybody for attending this session. Again, I can't thank ITM enough for allowing me to collaborate with them on this. Solar's not going to go away, everyone. I mean, it's going to stay around for a while. But thank you, everyone. I'll go ahead and turn my camera on here, and we can take any questions that we might have.
Perfect. Well, first off, Sean, thank you very much for the presentation. As mentioned in the intro, we did cover a lot. Luckily, we have about 15 minutes or so to take advantage of having Sean with us today. So please take advantage of his expertise and his experience. Ask any and all questions that you possibly can. Do so by using the question feature. A quick note, we did cover a lot of product-specific items within this webinar. If you have any questions that refer to pricing, availability, very specific application specification questions, you know, looking at a power quality or a thermal image or anything like that, we'll be happy to address your question privately and one-on-one, either myself or one of our technical sales team. You can find all our contact info along with our product list, pricing, availability, technical data sheets, manuals, etc. at itm.com. You'll also find the many ways that you can contact us, whether that be via phone, via email. We also have a live chat during our working hours. that you can connect directly with the technical sales staff as well. We did have a few questions that came in during the presentation. John asking about a copy of the presentation. Once the presentation is over today, we'll do a little bit of editing and do the fun stuff on our end, and then we will send out a link to all the participants on all the registries, so that you will have a copy of the presentation via YouTube link. If you'd like a more in-depth copy of the presentation via the PowerPoint, please contact us, and we'll see if we can get something available and sent out to each other. So again, use the question feature. Take advantage of the 10 or so minutes that we have Sean connected with us. So first off, we talked a lot about maintenance. We talked a lot about the tools needed to be able to go in, whether it be installation, maintenance, and troubleshooting, etc. Is there anything that Sean or Fluke would recommend as a startup kit? We talked about DMMs, we talked about imagers, but is there anything in particular that someone starting in the game would say, hey, I need these blank tools to go out?
Yeah, for sure. That's a great question. I mean, having a DMM or a clamp meter is one of the key components. During any electrical, you need to know what you're getting your output. So having just that clamp meter or an irradiance meter would also allow you to really validate and troubleshoot. If you're going out even on that residential side, you're starting in that market, which is a huge market right now. You're going to have your hand tools. You're going to be the one going up on the roof, or maybe it's a fixed mounted outside, but you're going to need to know what your voltage and your irradiance is going into that. That's really going to be your key wins. Now you can add thermal, on that later on, but you're going to be able to do some quick troubleshooting just with that clamp meter and that irradiance meter. That really is your two main components on that. Now, later on, Fluke is going to be launching an IV curve tracer. And this would allow you to go in and validate what your curve looks like. That'll help you for any warranty aspects of your solar panels, but you can kind of see what your output should look like. But yeah, definitely first and foremost, a good clamp meter that's cat rated appropriately and an irradiance meter.
Fantastic. So again, 10 or so minutes, please get your questions in. If you do have any questions that come in after the presentation, again, go to itm.com, find out our contact us page, and connect with one of our technical experts. If our technical experts cannot answer the question themselves, we'll be able to get in touch with someone like Sean to be able to answer any and all application-specific questions, so please don't be shy. We do have a question that came in from Mark. It is a little bit on the longer side, so please bear with me. So Mark says, how can the large battery storage in some of the new electric vehicles fit into a modern residential PV system? It's a couple of parts to the question, so we'll split it up.
No, and that's a great question, Mark. So if you think about your PV system and it's outputting, you've designed it to output to, say, potentially your electric vehicle, and you're using that to charge your electric vehicle. They are now they're not mandating, but there is discussion of potentially using your electric vehicle's battery banks to then backfeed back to your system or back to the utility. And now there's a lot of controversy and there's a lot of discussion on that, and people make way more money than I do, I'm sure, having those discussions. But it is an interesting time in life right now with the solar panel installations, the battery backups that some of these have, and then being able to utilize the electric vehicles batteries as a backfeed back into the system. I was looking at a Ford, there's a Ford pickup out, and they swear that you can use the Ford batteries to to basically energize your house for 2 days. So that's an interesting concept. But again, how are you doing that, going from your truck back through the charging station? Or is there an adapter that plugs into an inverter that then plugs back into your house? There's a lot of conversation with that. I mean, there's a lot of technical stuff that would have to go involved in that if you wanted to literally use your vehicle. I've heard that in Australia, solar's really big on the residential side, and they have a lot of battery backup systems. The utility actually has access to a residential's battery backup system and can turn it on and open flow based on grid demand. So I could have the charge there in my house ready for my own personal consumption, but yet if there's a peak demand on the utility side, they could actually pull from my own battery banks. Now, I'm sure there was legislation that went into that, and I'm sure, Mark, there's probably legislation that's going to have to happen to make all of that, if you're going to utilize the battery of your vehicle back into the grid or back into your house, or but a great conversation piece. But yeah, if you really want to get involved, go to some of the trade shows like Inner Solar. It's called now RE Plus. It used to be called Solar Power International. There's a lot of great meetings that take place during these events, and you can really get in on and hear some of the conversations happening about grid, solar, microgrid. I mean, we didn't even talk about the microgrid aspect of this, about communities grouping together, a block, a cul-de-sac, and they decide to put solar on everybody's houses and they're utilizing that. And conversations of, I have solar on my house, but you have an electric vehicle. I'm going to sell you my solar from my battery back to charge your electric vehicle. There's a lot of legislation, and it's going to be on a state level. Oh, Mark, you opened up a whole plethora of conversation on that one, brother. Yeah.
I like that. Well, in that spirit, if anyone else has any questions, we have about 5 or so minutes, and I'd love to stir the pot. I'd love to continue to stir the pot a little bit more. So please, again, use the question feature. I'll just remind everyone, if you do have any product-specific questions, if you have a thermal imager right now and you're not sure it's the right one, as you expand into this field, into these types of applications, and you want to see, verify if you have the right one or if you need an upgrade, itm.com, you contact us. We'll be happy to help you. We have a lot of very experienced technicians and technical sales staff that can help you in selecting these and going from there.
I can just say this is not going away, ladies and gentlemen. So either grab onto it and ride with it and adopt it. I think more utilities are adopting wind and solar as part of their platforms to help maintain the grid. And again, with so much information just on this topic alone, just the EV one will be just as packed. There would be no way we could cover both of these topics in one session like this. There's just too much, for sure. Yeah. So stay tuned for that EV one, because that'll be another great one. It's very controversial, because if you think about it, there's a whole grid that needs to be in place prior to adopting electric vehicles out into the system. Are the batteries going to be able to handle the distance? I mean, that's a whole nother conversation of just what's happening on that level.
As a reminder to all, great segue, we will have upcoming information on the EV presentation, whether it'll likely take place early on in the new year. So we will keep everyone informed about that. Let's see, pardon me. Paul, thank you very much for the feedback. That was just someone thanking us for the presentation. We have a couple minutes. Again, if you have any questions that come up, in the next minute or so as I talk, that, light bulb goes off and you have a question that comes up, again, ITM.com, you can find all the information based on the many different products that we spoke about today, as well as our contact info. You can give our technicians a call, our technical sales staff a call, and we'll be happy to answer your questions in that regard. And looks like the questions have dried up for now. So what I'll do is we'll be respectful of everyone's time, let everyone get out a couple minutes early and get on with your day, and hopefully spur those questions after the fact so that you can contact us afterwards. So on behalf of ITM University, we want to thank everyone for attending today's webinar, and a big thank you to Sean for presenting today's.
Thank you.
And so again, we are available to help you with anything and everything that you possibly need. ITM.com, find all the information there, contact, everything, etc. At the end of this webinar, we are going to have a short survey we'd like you to complete. Your feedback goes to assisting us improving these webinars, as well as bringing subject matter and topics that are of interest to you. So please take the time and fill out that survey. We do have one more webinar scheduled for the calendar year of 2022. The information can be found on the trainings page at itm.com. And along with the EV presentation and all the other webinars that we have scheduled for 2023, that should go live sometime in December, if not January, on our website. So please be sure to check us out there. And don't forget that as a thank you for attending our webinar today, your name is going to be entered into a draw to win $100 on your next online purchase. So the winner will be announced on our social media channels. So please be sure to check us out there. Once again, a very big thank you to Sean, a very big thank you to all of you who participated in today. Please have yourselves a great day.
Be safe, everyone.